Alright, today we're going to look at finding an oblique asymptote. An oblique asymptote is a diagonal line that the function approaches as x goes to positive or negative infinity. So, I've got a little sketch of a rational function here, and as you can see, this little dashed line in red represents the oblique asymptote, and that just so happens to be at y equal x plus 1. So the question is, how do we know when they exist, and if they do, how do we find them? So let's take a look at an example. Alright, so first off, when do they exist? Answer to that is when the degree of the top minus the degree of the bottom equals 1. So that means that the top exceeds the bottom by 1 in terms of the degree. Okay, so an example of that would be like x squared plus 4x minus 5 over x plus 1. Okay, so if you notice, the degree of the top is 2, the degree of the bottom is 1. So now that we know when they exist, how do we find them? So you find it using polynomial long division. So we're going to take x plus 1 and divide it into x squared plus 4x minus 5. So what do you multiply x by to get x squared? That would be x. So x times x gives me x squared. X times 1 is x. Switch your signs. You get 3x minus 5 remaining. X times 3 gives us 3x, so plus 3 up here. 3 times x is 3x. 3 times 1 is 3. Switch your signs, and we get negative 8 as our remainder. So the quotient in this, the x plus 3 at the top, is the oblique asymptote. So if we take a look at the graph, we have x plus 3, it's got a y-intercept of 3, slope of 1, so draw a little dashed line here to represent that. Alright, also if you notice, the bottom is undefined at negative 1, so that would be a vertical asymptote. If you have an oblique asymptote, you will not have a horizontal asymptote, because if you remember, if it's top heavy, horizontal asymptotes don't exist. So now, if I want to finish my graph, I'll factor the top. That'll factor as x plus 5, x minus 1 over x plus 1. Now when the top is 0, that is an x-intercept. So the x-intercepts for this would be at negative 5 and positive 1. So going back over to my graph, I'm going to cross the x-axis here at 1 and again at negative 5. There. So my graph is going to do this. it crosses the y-axis at negative 5. I probably need to put that in there. 1, 2, 3, 4, 5. So it's going to come down like that, and also back up and approach that diagonal line. This one is going to come down and then again up, and that would be the graph of f of x equal x squared plus 4x minus 5 all over x plus 1. So, in summary, how do we find oblique asymptotes? First off, the degree of the top, or the numerator, must be 1 more than the degree of the denominator. If that is true, then we perform polynomial long division. And the oblique asymptote is the quotient.